Do you want to start using Kubernetes in your company, but you don't know where to start? So you can start using Kubernetes in a cloud environment where you will learn how to use Kubernetes instances, what is a pod, what is a service, what is an ingress, and so on. Or you can install an instance on your own servers, and then you can get a bit deeper on how Kubernetes works in general. In this video, we are going to go through the steps on installing Kubernetes on a Linux machine, because this is important for some clients where, especially enterprises, where they want to safely deploy an application into their own self-managed Kubernetes instance. We are going to use Kubernetes documentations, and we are going to use Kubeadm to install Kubernetes on a Linux machine. With that being said, let's get into it. Well, before we start, I thought it's good to go through the terms that we are going to use inside the video. So we have Container Runtime, which is the lowest level. It's responsible for running the containers. Kubelet knows how to tell the Container Runtime to start or stop a container. API server, like a group of the endpoints on the API server, are responsible for telling the kubelet which container should go up, which one should go down, and so on. It's basically the main service. And there are other endpoints which are responsible for networking, secret stores, and so on. Insatll is the kube control. This is the CLI tool which communicates with API server and is for managing your cluster. And then on the left side, we have the Kubeadm. Kubeadm, like a kube administrator, is responsible for building a cluster. This is the official tool from Kubernetes. We are going to go through the steps of how to build a cluster with Kubeadm, but there are also other tools to use. For example, K3 is from Rancher, and that tool, I have used it before for installing Kubernetes on Raspberry Pi clusters. But in this video, since it's the official one, we are going to use this to install Kubernetes on a Linux machine, an Ubuntu Linux machine. So with that being said, let's get started. We are going to install the latest version of Kubernetes, which is version 1.27, and as you see, after version 1.24, they have removed the direct integration for supporting Docker as Container Runtime. So for that, we are instead just going to use the container D, and in the documentation, there are different approaches to install it, and we are going to just go through the installing it from the official binaries. I'm going to fast forward and just run the commands, but the link to the commands will be available in the description. So it's time to install Kubeadm. So we need to install Kubeadm, Kubelet, and Insatll. But before doing that, these are the requirements that are needed to install Kubernetes. The most important one is swap. When it is enabled, so as it is mentioned here, Kubelet will not work properly, and it's because swap is for handling the memory when the RAM is full, so it will put the information into a disk space. But this should be handled by Kubernetes, by Kubelet itself. So we are going to disable it. This is the first thing that we are going to do, and then we will install all the packages. And let's see what should be done after we have everything installed. But it is not running, and the reason for that is that it is not yet configured. It doesn't know what is the container runtime that it needs to control, or how is the networking working, and so on. And if you notice, inside the Kubernetes installation documentation, it also says that the kubelet now gets into a crash loop until we tell Kubeadm how to configure it. So now actually let's see how we can initiate Kubeadm. For that, we either can use the arguments directly in the command line, or we can use the config file, and I prefer the config file, and I have already added the config file for the Kubeadm, and I'm going to explain what's happening here. So the first part is where we are going to configure Kubeadm, and the second part is for configuring Kubelet. The networking part, the pod subnet, is the CIDR network block that we are going to assign to the pod networking in Kubernetes, and it's going to pick this range of IP addresses from the CIDR block. Make sure that this is not conflicting to any of your existing CIDR blocks. If so, just simply change it. And later we are going to install a network add-on for Kubernetes, and we have to also consider the change, so the value from here should be the same as the one that we are going to have inside the network add-on. And the next one is the control plane endpoint. This is for high availability purposes. Basically, this is just the address to your load balancer. I have added it with the DNS, so later if my IP to the load balancer changed, I can simply change this. If you don't set it and you want to convert later, it is not possible. So make sure that you already have, if you want to have a load balancer later, to have the master node to enable high availability on the master node, make sure that you have this enabled. I'm going to also explain later when we have it running the difference between a master node and a worker node, and what if you want to mix them together on one machine and so on. The next property is the Kubernetes version, which we are going to install. And then the next section is the kubelet configuration, and here we are going to only set the cgroup driver, and the cgroup driver, like the control group, is responsible for giving the resources to the pods. So this should match the Container Runtime's cgroup driver, and for now we are going to set it for kubelet. And later, if we got into issues with containerd, we are going to also see how we are going to configure it on the containerd. But for now, let's try to run kubelet to initiate Kubeadm to see how will it work out, what are the challenges or so. Now let's run the Kubeadm init command and see what will happen. So sudo Kubeadm init config Kubeadm config memo. Okay, so as you see, the IP forward must be enabled, and the bridge NF call IP tables is required for the CNI in Kubernetes, the container network interface. And to enable that, we had to look into the documentation. And here is the steps to enable them, so I will just fast forward it to enter these informations, and then we will check or verify if they are all enabled. Okay, so now the commands are ran and executed, so let's see how can we verify these. So let's do this one. So let's see if the modules are enabled. Okay, so now that we have executed these commands, let's verify that the IP forward is enabled. Okay, so now it should be fine. So now let's run the Kubeadm init and see what will happen. Sudo Kubeadm init config Kubeadm config. So this may take a while. As you see, it is now pulling the images for running Kubernetes, and we are going to get back when the the polling is done.
Many minutes later.
So at the end, when the control plane is initiated, you have to see a message like this at the end, which means a successful installation if you have followed all the steps that we had throughout the video. And so here one important thing is that you should now deploy a pod network to the cluster. But what I'm interested in before I do anything with Kubernetes itself is to let's first configure our kubeconfig information, and then we are going to check the status for Kubelet. So I'm going to run these commands quickly and see how's it with Kubelet right now. So as you see now, my kubectl command is successfully connected to the API server, and I could get the status of the nodes, but as you see, it's not ready. So now actually we can also see the kubectl config view, that where is it connected to. As you see, like it is connected to the DNS that we gave the address to. But now let's see the status of the kubelet. So systemctl status. So this is running. Now let's actually, so we don't at the moment need to configure the container D, but later it may be needed to configure the cgroup driver also on the container D, but for now it should be okay. But now let's go further with the Flannel installation. So now it's time to install Flannel. One way is to use the YAML file to install it, and the other one is to use Helm, and it is pretty straightforward in both cases, but this one is not really preferred because if something changes inside this YAML file and later you want to delete a distribution, a version, and then install a new one, something may have been changed and the older installation cannot be removed completely. But if you use Helm, then Helm will set a flag, a Helm version and a revision on the release, and then it is easier to remove it. So I think let's install Helm on our machine and then install Flannel. So now let's install Helm. As you see, it is pretty straightforward. It comes with the package manager. So we are going to just simply run the commands. And now we have access to Helm. So now I would say let's go back and see how we can install Flannel. So it says, so we have to create a namespace, and then we are going to add the repo and install Flannel. And this is where we have to configure our pod subnet. So let's just go on and then copy the values, copy the commands. I think. Update. And then now this one. And then if you remember, we have set this to 006 just to make sure I have this here, that's true. And then so Flannel is up, so now let's also get its state. Pod initializing, now it's running. So as you see, the core DNS was in pending mode, and the reason was that the core DNS needed this pod network add-on. So now our machine is running. I would say let's actually get the node information as well. So as you see, the node now is also ready, but as you see, the role of the node is only control plane. And now we go further and see why does that matter. But before that, we are going to, in the next step, we are going to deploy the Kubernetes dashboard into this cluster. And then we are going to try to access this cluster remotely with kubectl from any other machines. So let's get into installing the Kubernetes dashboard. So here is the Kubernetes dashboard. Now let's actually install it because it makes it much easier to access the to see the pods, the resources, and so on. So I will just go on and install it directly here. It rarely happens that you need to change or update this one. So let's run the command. It's not copied. Okay. So here, as you see, they will stay pending, and the reason to this is that, as I said, we are running on a control plane, and by default, under the control plane, none of the there's no pod can be scheduled. So, and that's by default true, and it's for security reasons, and because mostly the master node, which is this one, this is a master node, this one will not have any pods running on it. So this is only for etcd and the API server and any kube system related pods, but the rest should be installed on the worker nodes. But it can happen that you need to install you need to have this one also as the worker node. So you have one fat machine and then you want to have it for staging, for example, and then your API server, like the control plane, is going to be the same as your worker and so on. So for that, you need to enable the scheduling. And that's so you need to run a kubectl command, and that's also inside the documentation. So here's the command which you need to run for making this also a worker node. So let's now try to get the pods, and as you see now the containers are being created. So because now they are scheduled, so then we will have the Kubernetes dashboard also up and running. So as you see now, Kubernetes dashboard is up and running, and that was the important thing about the control planes. And it is important that always keep a very small machine for the control plane, because it doesn't matter, nothing specific huge is going to run on it, and your workers will just get connected to it. So now let's actually get into how to access this dashboard remotely. Okay, to access our cluster remotely, we need two things. One is the address to the cluster and the certificate which is used to encrypt the connection. And the other is the cluster admin service account. So if you look into the documentation for the dashboard, it gets you here for creating a sample user. And then you can create a token, and then you can give the token for logging into the dashboard. So I have created the file already, so let's put it together. So cluster admin.yaml, and this will be our file, and simply apply it. And now, as it says, you can create a token like this, which is this command inside the documentation. We are going to need this command, this token to log in into the cluster. But first, we have to get the cluster information. And that information is already available under home and queue. So the config file, this one is needed to be copied into your remote machine. For example, in my case, it's Windows, and you can use the scp command like here to say, okay, I want this file from this remote machine to be copied into here. And then, so this .cube should be available under your current user, for example, on Windows. And you also need to install the kubectl in Windows, so that would be, you can check it out in Kubernetes documentation. It's pretty straightforward. Just do choco install Kubernetes CLI, and then you will have access to kubectl commands here too. So as you see, I already am running this, so I have already copied this inside my machine, in the local machine. And now let's see if this token actually works. So I'm going to run the kubectl proxy here, and this was my token. So if I now access localhost 8001 and copy the token, so I should be able to access the cluster. So now I can see the dashboard, I can see all the pods. If I come here, then I can see everything that's deployed here and is running and so on. I can see the nodes. So this is one way to log in, and actually let's do one change. So inside your config file, you can also log in with the config, so you don't need to generate this token or store it somewhere always, since this file is always protected. But take care that we later are going to, in the next video, we are going to configure new service accounts which are limited to specific actions, and then we are going to give them to different user roles and so on to administrating this cluster. But for now, I'm going to copy this, but before I do the copying, let's run this one more time. I want to show you what will happen if I log in with the config now. So if I select the config and login, it will tell me there is not enough data. And in order to make that work, you need to add a new line there and then copy your token there. So it will be something like this. So under the users inside your config, where it is under the kube config, you can add this token line which you got, and this token is related to this user. Save, and now get the config again, refresh the page, config, sign in, and now it can read the token and then come here, so you don't need to generate the token every time. But basically, I think the token is going to be the same every time that So yeah, this is for today's video. As you see, now I'm connected to this cluster remotely, and so if I come here, I can see the information for this cluster and so on. And this is the CIDR that we have configured, and this is Flannel that we have deployed with Helm. So in the next video, we are going to try to add a new node to this cluster and see how this worker and master node and stuff would work. But for now, that's it. Thanks for watching. Don't forget to subscribe. And if you liked it, just smash the like button and have fun coding.